Hello everyone. Let us see the second question in the sample paper of the CBSE 2025. The question goes like this. A conducting wire connects two charged conducting spheres of radii R1 and R2 such that they attain equilibrium with respect to each other. Two different conducting spheres are there. One has a radius of R1 and the other has a radius of R2. Okay. The distance of separation between the two spheres is very large as compared to either of their radii. That means the radius of the sphere, first sphere, and the radius of the second sphere is too small when compared to the distance between them. Okay. So just like that I have drawn here. It's not that much accuracy for the scale. I have drawn R1 R2 also here in a bigger way, but actually R1 and R2 are very small compared to the distance between the spheres. Now what is the question now? The ratio of the magnitudes, that is what they are asking here. The ratio of the magnitudes of the electric fields at the surfaces of the spheres of radii R1 and R2 is. So what you need to find now, you have to find E1 divided by E2, that is equal to question mark. That is what you need to find now. So what is the equilibrium first of all? So I have drawn the two spheres here with radius R1 and R2. Now see what is the meaning of an equilibrium. What happens at equilibrium? At equilibrium, potential on the surface of the large sphere is equal to potential on the surface of the small sphere. So that is what. And you know all potentials formula, 1 by 4 pi epsilon naught Q by R. But in general we write V is equal to KQ divided by R. This is the formula generally we use. Yes or no? So therefore V1 is equal to V2. KQ1 by R1 is equal to KQ2 by R2. And both sides you can cancel out K and K. Then bring Q to this side. Q1 by Q2 is equal to R1 by R2. Then after that, let's go for the formula of the electric field. And we all know the formula for electric field E is equal to 1 by 4 pi epsilon naught Q by R square in general. Okay. So now here we write in simple, this we take as constant K, KQ by R square. So in general for the first sphere it is KQ1 by R1 square. For the second sphere it is KQ2 by R2 square. Now what we need to do, we need to find the ratio of them. E1 by E2 is equal to KQ1 by R1 square whole divided by KQ2 by R2 square. So that is what I have written here. Then you can write it as KQ1 by R1 square. Here the denominator R2 square comes up because it is like A by B divided by X by Y. It comes A by B into Y by X in mathematics. Yes or no? So in that way it comes KQ1 by R1 square into R2 square divided by KQ2. Once again you can cancel out K and K, and then if you go and solve it, you will get, yes, you will get E1 by E2 is equal to, now you can see here this Q1 divided by Q2 I wrote here, and R2 square divided by R1 square I wrote like this. But from equation 1 is above, you can go and see here, this is equation 1. Here you have Q1 by Q2 is equal to R1 by R2. Okay, Q1 by Q2 is equal to R1 by R2. Substitute that here. So Q1 by Q2 is equal to R1 by R2. Substitute here R1 by R2. R2 square by R1 square. So cancel out R1 and R1 in numerator and denominator. R2 and R2 in the numerator and denominator. So in the numerator you have 1 R2. In the denominator you have 1 R1. So finally the answer is E1 by E2 is equal to R2 divided by R1. So this is the answer. This answer is in option B. So let's go back to the problem and see. So now here 4 options they have given. that is R1 by R2, R2 by R1, R2 square divided by R1 square, R1 square divided by R2 square. But what we got, finally the answer is R2 by R1, that is in option B. So thanks for watching. God bless you all. We'll meet in the next video with some other questions. Bye.